So we have another basic rational function. Some books will give it a name. They'll call it the reciprocal squared function. Anyway, it looks like this. F of, why does it have that? F of x, nice F, huh? Okay, is 1 over x squared. Okay? Now, if you were to make a table of values and graph that, think about putting in 0. Well, you can't put in 0, right? So we know it doesn't, that's not part of the domain. 0 is not part of the domain. So the domain is from negative infinity to 0, and then 0 to infinity. And if you were to put in 1, you would get 1. And then if you think about putting in like 2, it would be 1/4, right? And then if you put in 3, it'd be 1/9. And so it's doing this. And then if you put in like 1/2, you're going to get 4. So 1, 2, 3, oops, 1, 2, 3, 4. Okay, so it's like up here. It's going up very quickly, quicker than the other one. It goes down quicker and up quicker, I guess. Also, something to point out is this is an even function. If you were to find f of negative x, that would equal 1 over negative x squared, which is the same thing as 1 over x squared. And so it's an even function. That means it's symmetric about the y-axis. So the point 1, 1 has another point, negative 1, 1. And the point 1/2, 4 has the point negative 1/2, 4. And let's see, when we put in 2, we got 1/4. And when we put in 3, we got 1/9, right? Okay, so there's the symmetry, and it looks like that. So I thought we would practice again the arrow notation. So I'll go from left to right. So I'm going to start here. As x approaches negative infinity, of x approaches 0. And then if I go towards 0, so as x approaches 0 from the left, then f of x approaches infinity, right? Because it's going off up. So it's going this way. All right. Now we'll go to the other side. So as x approaches 0 from the right, then f of x is approaching infinity, right? It's going up this way. And then as x approaches infinity, so going off this way, down that way, then f of x is approaching 0. Okay, so a little more practice with the notation and what everything means. This idea that it's an even function is because all the variables have even exponents. And that's really nice because you get that symmetry, and that's helpful when you're graphing them.